Welcome to the PhysicsPlace, the place to learn about physics, and in this video I'm going to explain how you can use the tangent line in position time graphs and in velocity time graphs. First we will start with this example. We have a position time graph, and as you can see the line here is a straight line, so the position and the time on the position time graph, so the velocity is constant. And if we want to calculate that velocity, we need the rate of change. Normally when you have a line you use this one, but now we already have some quantities on it, so here will be the position and here will be the time. So if we divide the position or the displacement, the change of position, with the time, then we get the velocity. And in this case it's easy because it's a straight line. So this is probably the equation you already know. The change of displacement position divided by the change of time, or in other words the final position minus the initial position divided by the final time minus the initial time, and then you will get the velocity. So first here we start with an initial time of 0 seconds and an initial position of 0 meters, and here we end with a final time of 12 seconds and a final position of 24 meters. So we can now calculate the velocity. We add it here in our equation and we have a velocity of 2.0 meters per second. And we can do this because this is a straight line. It gets a little bit more difficult when you don't have a straight line like this anymore. Now the velocity is not constant, so depending on the time you're looking, the velocity is changing. And as you can see, the rate of change is going lower and lower, so the velocity is actually going down. And now if you want to determine the velocity on a certain point, you need the tangent line method. So if you want to determine the velocity, for instance on 5 seconds there, then you cannot use the previous method, but you need to draw a tangent line. And it will look like this. So the tangent line, it hits here the line at 5 seconds, but it doesn't go through the graph. As you can see, it doesn't go through the blue line. For instance, this is called a tangent line. For instance, if you draw it like this, it also hits the same point, but as you can see, it now crossed the line, and that's not allowed. You have to only hit the line. So this is not a tangent line, and also this is not a tangent line because again it's crossing the blue line and it's not allowed to cross the blue line. So it will look like this, and now as you can see we have a straight line, and from this we can calculate the rate in change of position and of time, and we can calculate the velocity. So we can now use this equation and we can get information out of this graph. So we select 2 points, one here and one here, try to take them a little bit further apart of each other, not too close. And now we can determine the change of time between those points and the change of position in those points, and then we can calculate the velocity of the exact point of 5 seconds. So the initial time was 2 seconds and the initial position was 6 meters, and here the initial time was 9.5 seconds and the position was 22 meters. So we can add it into this equation, and then we can calculate that the velocity at time 5.0 seconds was 21 meters per second. The same can be done for this line. As you can now see that the position time line is going downwards, and again it's not going in the same velocity, so the velocity is changing all the time. And if you want to determine the velocity at 9 seconds, so at this point, then again you need to use a tangent line method. So you have to draw the tangent line which has the same slope as that point there, so it's hitting the line but it's not going through it. And now you can select 2 points on this line. So for instance this one, it's readable, it's good because it's just at the cross between 4 and 26, and this one is also good. We will try to choose them further apart like this. So now we have the initial time 4 seconds. We have the initial position 26 meters, and here we have the final time 14 seconds and 10 meters. And of course it doesn't matter if you have taken this point, you will have different numbers here, but if you put it in this equation it will be the same answer. So now the speed is minus 1.6 meters per second, because you actually here, as you can see, the position went down, so it will be a negative number and the speed is negative, and you can see that because the line is going downwards. So this is a negative velocity of minus 1.6 meters per second. Another example, we have to determine the velocity at 4.0 seconds. So we use the tangent line method. Now as you can see it's nowhere that it's easy readable, so we will just select this point, and this point, the further apart the better. Here the initial time is 0 seconds and the initial position is around 3 meters. Here again the time is 11 seconds, and as you can see it's not 80, it's a little bit lower, so around 78 meters. We can use this information to determine the change in position and the change in time, and then we can calculate the velocity. So the change in position and then the the velocity, which is 6.8 meters per second. So this is how the tangent line method works when you have a position time graph. If you have a velocity time graph, then you don't calculate the velocity because you already have it, but you will calculate the acceleration. So the rate of change in this graph will be the velocity divided by the time, which will actually give you the acceleration. So from these graphs you can calculate the acceleration. So for instance, in this example, the initial time is 0 and the initial velocity is 0 meters per second. The final time is 12 and the final velocity is 24 meters per second. And if you then calculate the acceleration, it's 24 divided by 12 equals 2 meters per second square. So this one has an acceleration of 2.0 meters per second square. Of course, with a straight line, you can just do it. But if you have, again, a line like this, then you need the tangent line method, the same as with the position time graph, but now with the velocity time graph. So now, if we want to determine the acceleration at the time is 4 seconds. So over here, we first have to draw the tangent line like this. Now you can see one nice point there, and somewhere here they're nice far apart, so they're good. This triangle will now have a change of time and the basis, and the height will be a change of velocity. So we have the initial time here, 2 seconds, and an initial velocity of 0.0 meters per second. Here we have a time of 15 seconds and a velocity of, let's see, 10 meters per second, and we can use this equation to calculate that 10 minus 0 divided by 15 minus 2, it's 0.77 meters per second square. So then we can calculate the acceleration of this point, and we don't know what the acceleration will do. It probably will go up towards here because, as you can see, the slope is growing bigger, but for now we know that the acceleration exactly at time is 4 seconds is 0.77 meters per second square, and the only way to do it is with the tangent line method. Two more examples. Determine the acceleration at time is 8 seconds and determine the acceleration at time is 12 seconds. So first we will do 8 seconds. As you can see, 8 seconds here, the line is going up here and the tangent line is actually going horizontal. Well, if the speed is not changing, so as you can see here, we have no acceleration. So let's see if we will also come up with 0 meters per second square. So first we take this one at the initial time 0, and here we take this one at the initial time 16. The velocity is around 21.8 meters per second here, and it's the same here. So although the time has changed, the velocity is the same. So if we now use this equation and we put our measurements in, then we see that the acceleration is actually 0.0 meters per second, because here we subtract 21.8 from 21.8. So it's 0.0 meters per second square. So there's no acceleration, and you can see that because the tangent line is going horizontally. So we put our answer in and we go to the next question. At time is 12 seconds, so that's over here. We draw a tangent line. We select 2 points. You can actually select the exact point where you drew the tangent line on and a point somewhere else, as long as they're pretty far apart. So now we have an initial time of 12 seconds and we have an initial velocity here of 18 meters per second. Here we have a final time of 16 seconds and a final velocity of 8 meters per second. And as you can see, the velocity went down, so probably we are talking about a negative acceleration. We will use this equation. We add our information into it and we have an acceleration of minus 2.5 meters per second, which is of course logical because the tangent line is going downwards. You should now know how to use the tangent line and how you can use it in position time graphs and in velocity time graphs. If you found this video helpful, please let me know by liking and of course subscribe for more videos. Thanks for watching.